So now today we are going to talk about yields of chemical reaction. Okay, clear? Right. So what exactly is the yield of chemical reaction? See, the thing is when we are working in the lab, we are not going to get 100% uh, products. Okay, it's not like that. Uh, we for example, if I'm expecting 10 grams of products, I will not get 10 grams of products. Okay, what will
Yes.
happen instead is that you'll always receive a little bit of less, because some of the material is wasted. So during the, say, filtration, some of it will stick in the filtration paper, and so on and so forth. Okay, so there's a wastage, and there's also some reactions which do not go to completion. Okay, so only a partial amount of that will go, and so on and so forth. So we are never going to get 100% of reaction. So how do we define percent yield of a reaction? We define percent yield of a reaction as actual yield of product, that is what we get in grams. Okay, what we got actually in lab. So percentage yield is something what we actually get in lab. And we divide it by whatever the theoretical, we know how to calculate the theoretical yields, right? Till now, that is what we have been doing, right? If this gram of this react, then what is the amount of the product? What is the amount of the... So that is the theoretical yield. Okay.
Okay.
So that is, we divided by that theoretical yield. And obviously for the percentage, we multiply it by 100. So this is the scene. Okay. This is how we are going to go. Okay.
Okay.
So now, for example, see, there's a one worked out example how we go about this. Suppose there's a methyl tertiary butyl ether, okay, MTB. You don't need to be concerned with the name, right? We just want to know its molecular formula, because I want to know its molar mass, right? I'm concerned with its molar mass. So its molecular formula is C5H12O, and it's a gasoline additive now being phased out in many places because of health concerns, right? And this is how we make it. Okay, we take isobutylene. Okay, again, this is name C4H8, and we treat it with methanol, and this is the methanol. Okay, and this reaction gives me methyl tertiary butyl ether, MTBE. Okay, this is what we get. Okay, so now they have asked that what is the percentage yield of the reaction if 32.8 gram of MTBE is obtained from reaction of 26.3 gram of isobutylene with sufficient methanol. Okay, so I have 26.3 gram of isobutylene. So right. So, and they are saying that we have got in, actually we got 32.8 gram in the lab. See, so they have given me the reactant 26.3 grams, okay, of isobutylene. So first I will calculate what is the theoretical yield. Okay, so how we will calculate the theoretical yield? Well, that is fairly simple. What we will do is, first we calculate the mole of isobutylene. Okay, and mole of C4H8 is equal to 26.3 grams and divided by its molar mass, 12 for the 48 and 56. So it will be 56 gram per mole. So this is the number of moles. Okay, got it?
Yeah. Yes, sir.
Okay, so it's same thing. Huh? So once I know the mole of this, I know that mole of C4H8 will be equal to mole of C5H12O, right? Because both the coefficients are 1, right?
Yes, sir.
So the moles will be same. So
Yeah.
let me calculate this. What is this number exactly? 26.3 divided by 56 is 0.4696. So, yeah, 0.47. I'll take it. Yeah. So 0.47 mole I will get. This is the 0.747 mole. Okay. This is what I've got. Now, I can calculate the amount which should be theoretically formed, right? So, what is the molar mass of C5H12O?
One sec.
It is 12 5 is 60, 72, and oxygen is 16, so it will be 88. Okay, this is 88 gram per mole. Okay.
Yeah.
So how we will calculate the mass of this? It will be simply 0.47 because that is the number of mole of MTB and multiplied by 88 gram per mole. So this is
Yes.
the theoretical yield. This is not the actually what we are going to get in the lab. Okay, this is something which we call theoretical yield. Okay, so if I take this number 0.4696 and if I multiply it by 88, I'm going to get 41.33 grams approx. 41.33 grams. See, so this obviously theoretical yield will always be more, right, than the actual yield, right?
Yes, sir. Yes, sir.
Right? Because in the actually in the when we are doing the reaction, actually materials are getting wasted, right?
Yes,
Okay.
sir.
So now theoretical yield is somewhere around 41.33. But actually what we have got in the lab, they have given us that actually we got just 32.8 grams. So what is the percentage yield? This numerator is smaller, denominator is bigger. This is the theoretical yield and multiply by 100 and we get 79.2%. Okay.
Yes, sir.
You are clear on this, right?
Yeah.
Okay.
1 second, sir.
Yeah.
Okay, so 41.333 is what they've taken as 41.4.
Yeah.
Okay.
Okay. Because they use the more precise molar masses. So okay.
Okay, but they have
Hmm.
asked for the percentage of isobutylene or
No, percentage of MTB, right? Because MTB is the product, right?
yes, sir. So in the same case, when they ask for isobutylene also it will
They will
be
not ask for isobutylene. They will ask for the product, sir. Okay.
okay.
Because the percentage yield is always of the products, huh?
Yeah, yeah, yes, sir.
Got it?
Oh, okay, okay. I'll just note that down.
Okay. Clear?
Yes, sir.
Okay. Now, similarly, you do 3.11. Okay. Now it's your turn. Okay. So ethyl alcohol is and 4.6 gram of ethylene is given. From this, we can calculate the moles of ethylene, and from there, I can calculate the moles of ethyl alcohol, and then I can calculate the theoretical yield for ethyl alcohol, right?
Yes, sir.
And I am also given the actual yield, how many grams I got in the lab. That is 4.7. Shabash, very good.
So to get the actual yield, right? Like the initial yield of the reactants.
Yeah, the theoretical, right?
Yeah.
The theoretical amount of products, right?
Okay, that will be 4.7, right?
No. That is, see, read the question. What has happened? We went to the lab and we treated 4.6 gram of ethyl and we got 4.7 gram of ethyl alcohol. Okay.
Yeah.
But what is the theoretically, how much we should have obtained? So theoretical, so this is actually we have obtained. This is actual. Okay.
Yeah, okay.
So for theoretically, we calculate, we forget this and we just assume that if it
Okay,
we are
so
given, then we calculate. Got it?
yeah, so for numerator, we'll take it as 4.7.
Sorry?
No, for the numerator, we'll take it as 4.7.
Yeah. But don't think like that, huh? Okay.
Yeah,
But yeah, that is correct, right? Because the actual yield is in the numerator, right? Yeah.
yeah. So it's actual yield divided by a theoretical.
Yeah. Actual gram, actual amount by theoretical amount into 100. Okay.
Thank you.
Okay. One second.
Yes.
When you are practicing at home, do not use calculator, okay?
Yeah, yes, sir.
But here we will not waste time.
Sir, 62.33%.
62.33% you are getting, huh?
Yeah.
Okay. One sec, let me check. 62.32. In the meantime,
Yes, sir.
go to the next 3.12, huh?
Okay.
3.11 you are getting 60.
2.33.
Yeah.
Okay. So 27.68 grams.
For 3.12, huh?
Yeah.
Okay. One sec. Let me check. Sorry.
So can you repeat?
I did not catch you. What?
No, sir. What did you say?
No, I did not say anything. I'm just checking. How much you got for A? 3.12? A?
27.68.
Yeah, that is correct. Yeah. Now do part B. Huh?
Sir, so for the theoretical mass of grams, right? We can take it as the previous one, right? That is whatever I got for the value.
How many grams of ethyl alcohol would be needed to produce 100 gram of diethyl ether, right? It's the same reaction, right?
Yeah.
Same equation. So now here we are given that we actually need how much? 100 grams, right?
Yeah, so I'll do mole of diethyl ether, right?
No, 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 no. See, it'll go like this. You are given the percentage yield, right?
Yeah.
0.87, right?
Yeah.
That is actual by theoretical, huh?
Yeah.
So actually you need how much? 100 gram, right?
Oh, yeah. And theoretically, you need?
So theoretically I can calculate from here, right?
Okay, yeah. Yeah.
So if so now I know the theoretical yield for theoretically this much grams, right?
Yeah.
So I know the moles of this, right?
Yeah.
So from here I can calculate the moles of this, right?
Okay, yeah.
And then I can calculate the mass. Okay?
Okay, so you calculate the moles using the theoretical value, right?
Yes, yes, yes. Right?
Okay,
Yeah.
okay. Sir, I'm getting 114.9 grams for the theoretical value. Should I take it as 115?
How much you are getting?
114.9. Or should I just take it as 114
Yeah,
point?
yeah. No, no, you take it one when it is point 0.5 greater than 0.5, then we round it off to the next one, right?
Yeah.
Next integer. So if it is 114.9, then we need 115, huh?
Okay.
But you just use 114.9 because you're using calculator.
Yeah. So I'm getting 142.6 grams.
You're getting 142.6 grams, huh?
Yeah.
So let me check. Mm, yeah, that is correct. Good. Okay. So now we are clear on this, huh? Okay.
Yeah.
So we can also since I'm recording this, okay, you go and revise, huh? What does it mean and all that. Now we
Yeah.
are going to do this important concept, huh? Reactions with limiting amount of reactants. Okay. So this is fairly important. So
Yeah.
what happens is that for example, if I want to make if I'm making ethylene glycol. Okay, this is a reaction where I'm treating ethylene oxide C2H4O with water, and I am using ethylene glycol. Okay, so let us say that this is a relatively, costly substance, ethylene oxide as compared to water. So what I want is that I will use excess of water, a lot of water, so that I don't want that any molecule for this should go free, because I want that every molecule of ethylene oxide should react and I should get this product. Okay,
Okay.
so I am using in this axis, using this in axis. So what is happening here is that we call ethylene oxide as limiting reactant, and this is going to decide how much product of ethylene glycol is going to get formed. Okay, so but first I'm just going to go to this uh,
Okay.
I I'll just add a page just below this, huh? Okay, below this topic I've added this page. So how we will identify, how we will identify limiting reactant. Limiting reactant questions. Okay, this is the thing. How we will identify the limiting reactant questions. Okay. So what we do is, first, the greatest hint is that when, let us say, I am given this equation 2a plus 3b give me 5c. Okay. Now in the question, suppose this is the question. Now if they say, if we take 4 mole A and 4 mole B, okay,
Okay.
or let's say 3 mole B, 3 mole B, then how many moles of C are formed? Okay, you got the question?
Yes, sir.
Now, the thing is, Ritika, we have studied that whenever we know the moles for one substance, we can calculate the moles of all the substance, right?
Yeah.
So immediately, how do we identify these limiting reactant questions? We identify these limiting reactant questions when the masses of both the reactants are given.
Okay.
That should immediately, ring a bell in our head. Oh, why have they given me both the moles or both the masses? Because with one I can do everything, right?
Yes, sir.
So that is the first thing. Now, how do we proceed? So what we do is A plus BB we used to have, right? Goes to CC plus DD. This is the general equation, right?
Yes, sir.
So we will compare mole A by A and mole B by B. Okay, what we will do? We will compare mole A by A and mole B by B. And the lesser one will be
Limiting.
limiting reactant. Okay, okay. All calculations, all calculations will be done on the basis of limiting reactant. See how we will proceed for this one. Okay, 4 mole A, 3 mole B. So it was 2A plus 3B goes to 5C. Okay, so and mole, we have to compare mole A by 2 and mole B by 3, right?
Yeah.
Step 1, compare. So how we will compare? Mole A is 4, right?
Yeah. So,
And that is 3. So we will compare 4 by 2 and 3 by 3. It implies 2 and 1. So which is less?
B.
So B is limiting reactant. Got it?
Mhm. Yeah.
So to calculate, so now to calculate C, we will use B. So how we will go? We will write like this. Mole B by 3 is equal to mole C by 5. See, I have not written mole A by 2 equal to mole C by 5, right? Because that will not hold. Now, this is the question of limiting reactant. Which will decide? Limiting reactant will decide. So, what we will use? We will use limiting reactant. Got it?
Okay, so you'll never use the excess reactant. It will be limited with.
Yes, because it is the one which that limits the formation of the product. Okay?
Okay, so even if there are like let's say three products, four products, all the products will
Will
be.
be formed on the limiting reactant only. Okay? Okay? Got it?
Yeah, and the product can be formed with another product, right? Like I can equate mole C by 5, let's say to, yeah, mole D by 6.
Yeah. That you can do, huh? Got it?
Okay.
So let us now. I have made this, huh? We have added 5C plus 6D also we have done. Huh? So we will use this. Got it?
Yes, sir.
So mole B by, so I'll use this 3 by 3 equal to mole C by 5. It implies mole C is equal to 5. Got it?
Yes, sir.
So, and similarly, you can calculate the moles of T. This is the first part they ask. See, masses will be given, which we will always convert to moles, and we will proceed like this. Got it?
Yes, sir.
Now, the next question they ask is, how many moles of excess reactant is left? Okay. Next question is, how many moles mole of excess reactant is left?
Okay, yeah.
Reactant is left. So I think it was 2A plus 3B, 5C plus 6D, right?
Yes, sir.
And so all of these moles have not reacted, right? Because A had 4 moles, right?
Yes, sir.
And this has 3, right?
Hmm.
So how we will calculate how many moles of A has? Again, limiting reactant will we decide. So we'll write like this: mole A reacted, because it is on reactant, so it will be reacted. On the right hand side, it will be produced. Okay.
Yes, sir.
So mole A reacted by 2 will be equal to mole B by 3. Mole B reacted by 3. And I know that all the moles of B have reacted because it is the limiting reactant. So this is the value I am going to put. So I will get mole A reacted divided by 2. So it implies mole A reacted is equal to 2, right? Right?
Yes, sir.
So mole A reacted is 2. So initial mole of A, how many initial mole of A were there? 4. Mole of A reacted.
Okay, it's 2.
So how many mole of A left?
2.
Initial minus reacted, right?
Yeah.
Which is 4 minus 2, which is 2. Got it? Clear?
Yes, sir.
So this
Sir,
is how we will proceed. Okay, this is what they will ask. Obviously, they will ask everything in mass term, but we can convert into, we have to deal everything there with moles, and in the end, we will multiply by the molar mass to get the masses. Got it?
okay. But sir, I just
Yeah.
have one more question. Like all whenever we use limited reagent and excess, right? Will
Yeah.
it always be like two reactants, or what if there are like three or four
Yeah,
reactants?
whatever reactants are, we'll calculate all the ratios. But for you, 2 are good enough. Okay?
Oh, okay.
Okay. So now let us, I'll give you this question. 3A plus 4B gives 2C plus D. We react 6 mole A with 9 mole B. Okay, 6 mole A, okay, with the 10 mole B. Okay. Now, first, which is limiting reactant? That is, you have to tell me in the A part. B part, mole C formed. C part, mole D formed. Okay.
Yeah.
And finally, you have to tell me mole of excess reactant left. Got it?
Yeah. Okay.
So these are the parts. Okay. Right.
So limiting reactant is B.
Limiting reactance Bombay. B4.
Yeah, B. Yeah.
Oh, how come?
Oh, okay. 10. Okay. Okay. One sec. I did 10. 4 by 10. No, it's A.
Okay.
Yeah. Mole of C formed is 4.
Mole of C formed is 4.
And the mole of
Okay, you do it and send it to me this time.
okay.
Yeah.
So for excess reactant left, you did 6 mole by 3.
See, we calculated how much has reacted by using the limiting reactant, right?
Yeah.
And once I know how much has reacted, I'll simply subtract it, right? Once
Yeah.
I know how much money I have used, I will immediately know how much money I had, right?
Yes, sir.
I'm left with, right? The same thing. Think of it as money, yeah?
Okay. So,
Yeah.
all right. For excess, you have given the number of moles for B is 10.
Yeah.
Yeah, but so basically when you do 6 by 3 is equal to mole B by 4, you get as 8 moles.
Here. So excess reactant is B, right?
Yeah, so it'll be 10 minus 8, 2 moles.
Yeah. Right. You have to send me, huh?
Yeah, I'm sending one cent.
Yeah. And don't ask me, huh? Have the courage to do it incorrectly because then you'll learn more. You're not getting the point. Okay?
Mhm.
Okay?
Yes, sir.
Does not matter. You see, don't be scared. You just do what you think. And then from there, use that mistake as the feedback. Okay? Are you
Yeah.
trying to understand what I'm saying? Okay. The mistake is going to tell us what we need to do, what we need to correct. Okay. But if we never commit the mistake, if we are afraid of the mistake, then we'll never learn. Got it?
Yes, sir. Yeah, I've sent it to you, sir.
Okay. So you calculated for everything, huh?
Yeah.
Great. So now this is clear, right? What we do in the limiting reactant. Okay.
Yes, sir.
So if we don't know if we are given grams, then Ritika, what we are going to do?
So if we are given
If we are not given the moles, if instead we know the grams, then how do we proceed?
same, it's the same way except we just like, use the formula gram by like
Yes,
mole.
yes. We calculate the moles first, right? Right?
Yeah.
Clear?
Yes, sir.
Okay. Now we'll come back to this. Okay.
Okay.
So I have this added in between this and okay. Now from here you can see which is limiting reactant, which is so on and so forth. Okay. This we don't know, but now see. Okay. Now you
Okay.
do this, huh? Okay. Although it is solved, everything is there, but you do it. Got it?
Okay.
Yeah. Very good.
So another doubt, right? So when I'm not using the calculator for the like the
In
molar,
the exam or in the school, huh?
yeah, for the molar mass, right?
Yeah.
Like can I round it off or I have to take it whatever they've given it as?
Whatever they have given it as, you can also round it off, huh? Because you anyways won't be calculating by using those much decimal places, right?
Yeah, because they'll either way like suppose it's like let's say for example like
I got it. I got your point. Okay, but in those cases, yeah, I mean you have to round off. Yeah, I
Okay.
mean, because something is better than nothing. Because if you're stuck so much in the calculation that instead of you just round it off and get okay.
Yes.
But but actually that won't be completely correct, right?
Yeah, okay. So depending on it, like if there's like two places of decimals, then I round it off.
If it is 10.76 or 35.45, something like that, you have to learn to divide and multiply. I mean, there's no beating here, okay? But usually, what they do in the exams and everything is that they will I mean, the in the competitive exams, or if the teachers are good, they will give you nice values. Okay.
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 I don't think so. Padma is going to do that though.
Yeah, I don't think so.
So yeah. So I think this is a question. If you, it is better put to her that what she is expecting out of you. Huh?
Yeah.
Ask her if she is expecting that you should fly also. Huh? Okay.
Uh,
Okay. And tell her that you are working on it. Huh?
yes.
See, students should be given calculators. We are not testing their calculating abilities, okay? But so, what are your hobbies? Do you play any sports?
Yes, sir. I play basketball.
Okay, very good. Yes. Yeah, it's very important to stay fit, huh?
Yes,
Okay.
sir.
That's the most important thing. In
Yes, sir.
spite of whatever anyone tells you, okay? That is the most important thing. Okay. Yeah.
Okay, so for potassium is 39.1, so I'll take it as 39.
Okay, take it as 39. Here, at least take it as 39 point. Yeah, but you can take it as 39. Take it, okay?
Okay.
Yeah.
So chlorine's molar mass is 312.
Uh, which reactant is what you are asking something?
Yeah, chlorine.
Chlorine molar mass.
Yeah.
Where is the periodic table?
Yeah. I mean, I searched it, it says 312.3.
For Cl.
Yeah.
No, 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 no. Must have searched something else.
I think it's showing for chlorine.
Chlorine is 35.45. Where is the periodic table?
So I have it. It hasn't come yet.
Okay. Well, how many days they are saying?
I mean, I haven't checked yet, but
Okay, please do check. Huh?
yeah, but I don't think it's coming anytime soon. Like,
Yeah, yeah, that I understand, but okay.
yeah, but
Because
yes, sir.
that is important. Huh? Yeah,
Yes.
just chlorine is 35.45. Huh?
Okay.
And you can also look up for the.
Ammonium and platinum.
Yes, yes, yes.
Yeah. Yeah, ammonium is 18, right?
NH3,
Yeah.
that is ammonia, and that is 17.
Oh, it's 70?
Yeah, it is 70, no?
Okay, over here it's showing 18.039
Where?
in Google.
Well, Google is something wrong then.
Okay, I'll take it as 70. Oh, and for platinum it's 195, right?
For platinum. Okay,
Yeah.
1 second. Do one thing. Huh? Take. Okay. See, the molar masses are given here. Got it? Okay.
Okay, 195.1. 39.1, okay. 35.5 and yeah, so you can take it. I've noted everything down.
Okay. You already have the equation or no?
Yeah,
Right.
equation.
Write
The
the equation. You have the equation, right?
yeah.
This is the equation already written, huh?
Yeah.
Okay. Great.
So for moles of potassium tetrachloroplatinate, I
Yeah.
got 0.255.
No, no, yeah, I just want the final answer and then you can check. Don't worry, huh? Don't worry. That is why you are asking me, huh? Don't worry, okay? Have the courage to do it incorrectly, okay?
Okay.
Yeah, yeah. How does it matter? You started shooting on the basketball, you started getting the points in the first place, right? You'll make so many mistakes and then you learn, right?
Yeah.
The same thing here.
Yes, sir.
Okay, you got it?
For the eighth part, yeah.
How much?
So for limiting reactant is K2PtCl4.
Okay.
Excess is the other.
Yeah. And how
Number is
many grams?
88.2 grams.
88.2 grams.
Yeah, I took it as 300 grams.
Okay.
It's 300.1. I took it as 300.
82 point gram you are telling, right?
0.2.
Okay. Yeah, yeah. Okay, great. Okay. So now you see what is your homework, huh? Okay.
Yeah.
I'm not seeing any homeworks from you.
I mean, I'll send it to you.
Practice, practice.
Yeah.
These are homework. And when you go to this, okay, chapter 3 at the end, okay,
Yeah.
you will see this limiting reactant section, okay? This,
Okay.
okay?
Okay.
So here, homework, homework,
Okay.
homework. Got it?
Yes, sir.
No problem.
Is there any class tomorrow?
I don't think so. We have any class tomorrow, right?
Okay.
I sent you the timetable. What does it say?
So the thing is, next week I cannot attend on Thursday, Friday because I have exams going on, like a physics
No
and.
problem, no problem. Then we'll skip Thursday, Friday, and we'll see how we can make up. Huh?
Okay, yes, sir. If we can keep Thursday, Friday class tomorrow and Sunday, like if you're free, right?
I'll just try, but I don't think so that will be possible because weekends are really busy. Huh?
Okay, yeah, sure. So you let me know. Yeah.
Yeah, yeah, yeah. Sure.
Okay, so,
Yeah. चलो ठीक है. Okay.
okay, so thank you,
ठीक.
sir. Bye.
Bye.